Question number 66 says that the number of distinct terms in the expansion of brackets x cube plus 3x cube plus 2 divided by x cube whole raised to the power 50 is. So we have to find the number of distinct terms. Let us simplify this expression. This is x cube plus 3x cube upon x cube, that is 3, plus 2 upon x cube raised to the power 50. Students, we know that the general term is 50 factorial upon a factorial, b factorial, c factorial, x cube raised to the power a, 3 raised to the power b, 2 upon x cube raised to the power c, where a plus b plus c is always equal to 50 and a, b, c are whole numbers. They can take value 0 also. Now students, we can clearly see that when I will take a is equal to 50, the maximum power of x will go to 150. And we can also observe a very simple thing, that the difference of the powers will be 3. 150, then 147, then 144 and so on. And the minimum power will occur when c becomes equal to 50, and that will be x raised to the power minus 150. So 50 powers of x on the positive side, 50 powers of x on the negative side, and one term which is a constant term. So number of terms will be 50 on the positive side, 50 on the negative side, and one term will involve x raised to power 0, 101. So be very careful students, we cannot apply the formula directly here. The reason is that the first term and the third term in this multinomial expansion, both terms are containing the variable x. So we cannot apply the formula directly. Okay. Option number 4 is the correct choice. Obviously, it is an intellectual question. Okay. Let us move on to 67. Question number 67 says that the number of numbers greater than 1 million formed with the digits 0, 1, 1, 3, 3, and then 5. So students, 1 million, that is 10 lakh. So 10, 100, 1000, 10,000, 1 lakh, 10 lakh. 1, 2, 3, 4, 5, 6, 7. So total of 7 digits must be there, because I have to form the numbers greater than 1 million. And 1 million is the smallest number of 7 digits. Okay. 0, 1, 1, 3, 3, 3, 5. So we have 7 digits in total. All of them will be used. So the numbers cannot be starting with 0, obviously. Numbers starting with 1. So starting with 1. How many will be there? Starting with 1 will be 6 digits have to be arranged. Out of them, 3 3s are alike. So 6 factorial upon 3 factorial. And that will give you 120. Starting with 3 now. So if you are starting with 3, you have 6 digits to be arranged. 2 1s are alike, 2 3s are alike. So 6 factorial upon 2 factorial, 2 factorial. And that gives you the answer as 180. Then the last option, the digits which will be starting with 5. So starting with 5. Now we will be having 6 numbers, out of which 3 3s are alike, 2 1s are alike. So 6 factorial upon 2 factorial, 3 factorial, and that will be equal to 60. 180 plus 120 is 300. Total answer comes out to be equal to 360. Okay. Option number 3 satisfies. Fine. An easy question. Okay. Given that you should know what is the count of 1 million, and you should know that how to arrange the numbers properly. Okay. Let us move on to 68. Question number 68 says that the number of words formed with the letters of the word Mahabalipur without changing the position of vowels with respect to consonants is n. Then the sum of digits of n is. Students, this is a line which is very tricky in itself. Without changing the position of vowels with respect to consonants. That means without changing the position of consonants with respect to vowels. That means the position of vowels as well as consonants is fixed. Okay. So you can only arrange the vowels amongst the position of vowels and consonants amongst the position of consonants. They cannot be interchanged with respect to one another. Okay. Consonant cannot take the place of vowel. Vowel cannot take the place of consonant. Okay. So let us start this question. The word is very huge. Mahabalipur. Mahabalipur. Consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. Such a beauty. Alternate, alternate, alternate. Consonant, vowel, consonant, vowel, consonant, vowel. How many consonants are there? M, H, B, L, P, R. How many vowels are there? A, I, U. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6 consonants and 5 vowels. 5 vowels will take the position number 2, 4, 6, 8, 10. 6 consonants will take the position number 1, 3, 5, 7, 9, 11. So the number of arrangements are number of possible arrangements. Students, for M, H, B, L, P, R, that means the consonants, all the 6 consonants are distinct. So we'll have 6 factorial multiplied by, for the vowels A, I, U, 5 factorial upon 3 factorial, because 3 of the vowels are alike, 3 A's are alike. So this is equal to 720 multiplied by 20, and that is 14400. I have to answer the sum of digits of n. This is the value of n. What is the sum of digits? 1 plus 4 plus 4 plus 0 plus 0. So 9 is the answer. Option number 1 satisfies. Okay. So let us move on to question number 69. Question number 69 says that the number of positive integers that are the divisors of both 10 power 10 and 18 power 11 is number of positive integers which are divisors of both. That means we have to find out the HCF of these two numbers, and then we have to find out the number of divisors of that particular number. This is the number 10 raised to power 10, which can be written as 2 raised to the power 10 and multiplied by 5 raised to the power 10. This is the number 18 raised to the power 11, which can be written as 2 raised to the power 11 into 3 raised to the power 22. What is the HCF? HCF is 2 raised to the power 10. What are the number of divisors which are positive integer for this number? That is 10 plus 1, and that is equal to 11. Okay, option number 2 satisfies. We have to find the HCF, we have to find the number of divisors of HCF. Let us move on to 70. Question number 70 says that the sum of first 20 terms of the series 3 by 2 plus 5 by 4 plus 9 by 8 plus 17 by 16 is equal to what? This is a very easy series. It has been asked multiple times. So this is S is equal to 3 by 2 plus 5 by 4 plus 9 by 8 plus 17 by 16 up to nth term. Students, observe the nth term. We have 2 power 1, 2 power 2, 2 power 3, 2 power 4. In the denominator, we have 2 power n. We have 2 plus 1, 4 plus 1, 8 plus 1, 16 plus 1. In the numerator, 2 power n plus 1. If an is 2 raised to power n plus 1 upon 2 raised to power n, and that is 1 plus 1 by 2 raised to power n, you have to find out S20. S20 will be equal to 20 plus a into r raised to the power n minus 1 upon r minus 1. So this will be cancelling on the factor of minus 1, because 1 by 2 and minus 1 by 2 in the denominator. So you have 20 minus 1 upon 2 ki power 20 minus 1. So this will give you 21 minus 1 by 2 raised to power 20, and that is 2 raised to the power minus 20. So all the options are written in this format. So let us see the options carefully. 21 minus 2 raised to power minus 20. Option number 3 satisfies. Okay. Once you identify the pattern involved in any of the series, you can solve all the particular series. Okay. Let us move on to 71.